I see 30 people. I don't really need to. I'm going to add a random location for the boundary conditions discussion. The only one that I remember is Paranal, so I'm going to put it there. I think that is not conflicting with any of the other locations. So I'm going to screen share. There's not much to share. I'm just going to screen share the tab for the breakouts. So I hope that you can see that. The plan for today is to talk about these breakout proposals, capture any other breakout proposals from the audience that hasn't put them on this list, but so that we can put them on this list. Briefly describe what the plan of work is so that people can evaluate whether they think that there is a session that they may want to join, or they want to work on another thing and create another session. And then Xiaolong Li will do a quick tutorial on selection of specific areas in the sky that you can limit the metric to run on. And in the process of doing that, he'll do it from start. So you'll see one more time how you log in on SciServe, you turn on your volume, you get on the right place, you open a notebook, and you start the notebook to interact with the LSST and math environment. So that will be a quick refresher.
Question in the chat, Fed. Is there going to be a leader for the breakout sessions?
I don't want to micromanage each breakout session. I think that should be a decision for the breakout session participants, how they do their format. We would like a point of contact. So, because as I mentioned during the day, Rachel and I will come to your sessions and we'll ask you, can you give us a quick report of what you're working on and what you have accomplished or what you plan to accomplish, so that on Wednesday at the OpSync session, we can report about what happened during the hackathon. So maybe think among yourself who the person is or how you want to organize that interaction with us. But even that, if you think that it should be a group interaction, I don't want to oppose that at all. So I guess to recap, the answer is that you do you, and if you have a leading person, maybe you want to put it on the spreadsheet.
Or at least nominate somebody to take notes.
Yes. And so if you put somebody on as a coordinator, I'll assume that people that are interested in knowing things about this session will go on Slack, can go on Slack to that person to communicate. Okay. So maybe one thing to do is also for me to open the Yo Tribe to remind you in case you didn't make it to the Yo Tribe portion of the session yesterday. So give me 1 second. To get myself the link, and I will show you just very quickly how Yo Tribe works.
And is there screen sharing in Yo Tribe? I'm just wondering for like trying to write code with someone.
Yes, there is. And fun fact, when I first got invited to Yo Tribe, you couldn't do that, which was a showstopper for me. But they enabled it very quickly after that. So yes, there is screen sharing within your subgroup.
Excellent, thank you.
So I'm still looking for the Yo Tribe link, so be with me for 1 second. Got it. So let me stop screen sharing so I can screen share the other thing. Stupid Zoom window that covers the stop screen share. Got it. And then screen share, and I'm going to screen share my Yo Tribe. So as a reminder, Yo Tribe will get you to a room. Share. Now you see my Yo Tribe. I'm already logged in. No, I'm not. Yes, I am. I'm already logged in, so I'm already on the panel. If I wasn't logged in, it would ask me first to take a photo and then to put in my name, and then it would take me directly to this room. And then once I'm in the room, this is me, you can either move with the mouse. So if you want to go to Paranal for the breakout session on boundary condition that we'll discuss in a minute, you can either click on that portion of the map and your icon will follow you, or you can move with the arrows. Right now I'm moving with the arrows. People reported yesterday that moving with the keyboard arrows is less buggy and more straightforward than moving with the mouse. And then, Will, do you mind if I join you in Serotololo? When I join somebody, I join.
You get horrible feedback.
So I join Will in Serotololo. I just go next to him. This creates a circle. Now we're in the same circle. We see each other. With this, I can make the circle the only thing that I see. With this, I can go back to the map. And if I want to leave the circle, I just move away. Bye-bye, Will. So that was a quick try demo. There's a bunch of questions. No, I think it's okay. We can talk about the breakout sessions. I think we can go down the breakout sessions one by one and ask for somebody to describe what they're planning for that breakout session, if that's okay. So we're starting with microlensing that will meet in Alma. Do we have a spokesperson or somebody that is willing to describe what that micro session is about?
I can do that. At least I can give a list of things that I think I want to work on, which I would like to collaborate with as many people as would like to join me. So I can act as the spokesperson for that.
Excellent.
Do you want me to have a quick recap of what I would like to?
I'll put you as coordinator.
Sure. Okay. So I was going through all of the material from yesterday, and our stated goal is to evaluate and compare the metrics for a range of the opsims for the metrics that we proposed, and now we have the tools to go ahead and do that. So obviously I'd like to move forward with that. I found some good places to start with some of the microlensing. Hello?
There was a comment? Perhaps carry on. Okay.
So I found some useful code in going through the Sims Math contrib yesterday. Peter Joachim has outlined a microlensing metric, which is a really good starting point for how we might extend that to incorporate some of the metrics that we built. We have some approaches that could simulate events per pointing and see how many could be classified as microlensing based on the alerts. So this touches on the need to analyze alerts that are still on the rise. So identifying a transient event that is still on the rise and therefore we could take follow-up observations for. So that's a different set of metrics. It's a use case that might be of interest to other science cases as well. Mike outlined yesterday one of the metrics we have for identifying events like that. So that is something I think we could simulate separately. Mm-hmm. We do need to add some catches to the metric code to avoid comparing opsims that have unequal exposure times. That was a gotcha pointed out by the math team that can lead to misleading results. So that's something that we need to take into account. And then we can encapsulate the code to produce metric bundles for different use cases, like, for example, stellar mass lenses versus compact object lenses, the Rubin survey overlap, and thought that is such a mouthful. And we can also talk about some figures of merit. And finally, but not least, documentation.
Excellent. I took some very, very quick and rough notes.
All
right. So I'll do that for all the other sessions as well. Please correct them if I capture anything wrong. Okay. So Nino pointed out that this is a very ambitious plan. There's nothing wrong with being ambitious. PhotoZ, does somebody want to be the spokesperson for that, or anyhow describe it to us right now?
I'm here.
Hello, yeah, Melissa, can you boost your mic?
No, but I could do this.
Oh, that's better, that's better.
Okay,
thanks.
Yeah, yeah, so we talked a bit about how to make a photo Z metric, how to distill like the whole photo Z simulation and all the statistics we can measure in different redshifts into something that can be easily ingestible. And we have some ideas, and we're going to keep going with those ideas today. So we actually don't need math stuff for that, because all we need is that math that gives us the depths, the co-added depths at a given time, and then we go from there. So going from there. Yeah.
Okay. So you're working on figure of merit instead of math?
Pretty much, yeah. Yeah, I think that's accurate.
Which is a figure of merit. Fine. Excellent. So the next one is the boundary condition breakout. I can speak to that. It's a little bit different than the other breakouts. It will not work on maths, and it will be a short one. I cannot spell my name while I speak. Oh, I can. It will be a short one, so it will be only 1 hour after the plenary. I expect it to last no longer than 1 hour after the plenary. This is for people that don't really want to focus on writing the code for the maths, but are thinking, because perhaps somebody in their group is writing the code, or because they're aggregating maths from different groups. They're thinking about how do we present this, and how do we make the results of the figure of merits comparable on a larger scale. So these boundaries, which we call boundary conditions, basically refers to how do we normalize the figure of merits, so that when the SCLC, the committee that receives the reports and looks at the figure of merit, sees that this one figure of merit is 0.8 and that one figure of merit is 0.4, they have a way to understand what that scaling means. So that's one thing that we want to discuss, basically, is how do we effectively how do we find a normalization that is a good scheme for all the science cases and figure of merit. And then the other piece is how do we split opsins in a group of opsins into quality cuts. So for example, inside of this set of opsins that are the weather family, we identify some that break a science case, some that are acceptable for a science case, and some that are good for a science case, so that the opsin team can investigate what has actually broken a science case inside of a family of metrics. So how do we set those how do we identify those points to split the efficiency of metrics in a way that is consistent among the figure of merits and among all the science teams? I would like one of the opsin people to be in this session to help us, guide us, and tell us if what we're thinking is reasonable and is going to be useful for the opsin. So Peter or Lynn, if you're available, I would like you to come to this session.
Question from Ashish in the chat. Are metrics for variables intended to be included in the transient light curve metrics?
So the transient light curve, so this is, I think I'll let the people in the transient light curve metrics group answer that. So Ashish, if you can wait, it's 2 groups down, so we'll get to that in a second. Also, Yair and Ashish are conversing about that. But perhaps Yair, hold that thought, and I will call you on that in a second. But just for the sake of avoiding organizational issues, let's go down the list. So crowded field photometry math.
I guess I can say a few words to that. So this is really, my intention of this is to have a session where people who want to make progress on how well LSST will actually perform in crowded regions in a condition-dependent way will impact the science that they want to do. So that might include if you have a science case where you know that you need to know, for example, the photometric precision at a particular depth, and you don't know how to get math to do that. That may be one thing to work on. Another that I'm personally very interested in is to try to make progress translating the math predictions for crowded fields into a realistic depth estimate based on experience. So I don't know whether we'll be able to get anything and end up with a revised new metric or a correction to existing metrics today, but my plan is to try to make progress on those two fronts.
Cool. So I capture identifying metrics useful to see how LSST will perform on a crowded field specifically.
I think that's fine. I can update that if you like, Fed, after the plenary. But I think what you have is good.
So next is the transient light curve metrics, which can I roll call Yair for that since you were giving answers? Are you?
Sure. Yeah, I put that one down because I was thinking of metrics about transient light curves, things like points before peak, points after peak, color points, time between points, things that are relevant for transients. And I think some of these have already been written. And so part of what I wanted to know is learn what's already out there and how to use it, and what else we need, and maybe write a few new ones.
I think for the status of the light curve metrics, since I am somewhat familiar with this, that's a great plan. There is a lot of material that has been written. A lot of it is certainly redundant. So I think it'll be a great plan to just like get a sense of what's written and what can be merged and what is missing.
Yes, so I started looking at the math contribution package. I don't know if there are other places we should look, but we can talk about that later.
There's a follow-up question. Oh, sorry, Nino, go ahead.
No, that's fine. I just want to point out that I posted in the chat this GitHub repository. I'm not really familiar with the person who wrote it.
It was myself and Stefano.
Okay. But I don't know if that's relevant to Yair. And well,
I saw that name on the list as well. I looked at the TDE one and I haven't yet gone into that one, but that's part of.
We can discuss at the breakout session.
Yeah.
I'll join that breakout session, and we can talk about that.
Yeah, and this is Ashish. So I am interested in transients, of course, but I don't want to see variables left out. And because I didn't see an item there, that is why I asked the question. So, but if there aren't enough people here in the 50 that are going to be around, then maybe we can take it up later. But it's something that we should keep in mind as a project.
Yeah, Ashish, I think if the spirit of this breakout is to identify, I don't want to give too much love to this breakout, but obviously my understanding of it is a little bit enhanced. If the spirit of this breakout session is to identify and review the metrics that are useful for transient, that is entirely applicable to variable.
Right.
And then we can see what's missing specifically for variable and for transients.
Yeah, makes sense.
I would like to invite somebody who has done Monte Carlo simulations on OpSIMs to come and work with this group. That knowledge will be super helpful because really things like the transient ASCII metric are kind of designed for dropping a bunch of light curves in space. So they're kind of designed for interfacing with the Monte Carlo environment. And I know that Peter can help us, but I suspect that there are other people that have done it and can also help us and set Peter free from some responsibility. Which brings us to the last proposed breakout session, the DCR, differential chromatic refraction. Who wants?
That in some ways is related to photo Z, and you know, there's a bunch of time domain stuff that's actually far more important, but I'm actually really hopeful that by the end of the day, we could get a real DCR metric done. So I want to focus on that. So basically, I think that means maybe 15 minutes of Peter's time trying to understand a metric that he has already developed related to this, right? So basically, you know, trying to figure out how well we can measure the differential chromatic refraction, how that maps to specific SEDs and redshifts.
Okay, so I'm gonna put here that your session needs Peter specifically, that the sessions before needs someone that can do MCMC in the OpSIM environment, in the OpSIM math environment. Any specific needs for the crowded field? Specific skills that are needed and missing?
I would probably like to ask one of our math experts to drop in during the session, just so we can ask them whatever questions occur to us when we're trying to navigate the crowded field metric.
Do you need? Do you mean a math expert, or you need somebody specifically from the OpSIM math team?
I suspect Peter and Lynn are both overbooked already, but if either one of them had time to check in, that would be great.
Okay, I'm gonna leave it at math expert. So somebody that feels comfortable helping out, even if they may not be. So Peter Orlin here. Orlin, I'm never gonna be able to spell your name after Leanne joined the team. Like my brain is gonna always have problems distinguishing. Furozi, do you need anybody? It sounded like you were, it was more of a domain discussion.
Yeah, I don't think we need any math experts or anything like that, but thank you.
Perfect. Microlensing?
So I'd like the microlenses, Mike in particular, since he wrote especially one of the metrics, and Peter, if he can clone himself 3 times.
So Peter, sorry, say it again.
If he can clone himself 3 times.
Peter, if possible. Okay. Anybody else wants to, at this time, propose a separate splinter session because they don't see themselves working with anybody, any of these groups, but they also would like to work with the team? You can propose it by speaking up or by typing it on the chat. If you want to propose it later, you can always do that on Slack. Offer going in 3, 2, 1, 0. Okay, so these are the groups, these are the official starting breakout sessions. And with that, I'm gonna stop sharing my screen. We can move on to Xiaolong, doing a quick recap. How do you start, go through the SciServe, get to a notebook, and then once you get to the notebook, he'll show you a notebook that selects specific areas of the sky, which you can use if you have a specific area of the sky that you want to investigate, say, for example, the Magellanic Clouds. Also, I think it can also be used to speed up the calculation in some cases. Kind of speculating on that. Xiaolong, are you here? Keep in mind, I want to give a shout out to Xiaolong that agreed to do this. So it is about 2 a.m. where he is, or 1 a.m. or something.
Oh, wow.
Because he's in China. And also, sometimes his connection drops. If it does, there is a video of this that you can also watch on your own time. But we'll give it a try and see if his connection can sustain this for the next 20 minutes or so.
Yes, okay. Can everybody hear me?
We can hear you fine, and you can share your screen, I think. You should be able to.
Yeah, I will share my screen. Okay, so first let's log into SciServer and go to the LSST container. Go to compute. LST container. Storage your folders. Here I saved in the Spatial selection notebook. I will post the link to the
Right, so this map is not pulled automatically inside. We didn't upload it into Gordon Richard's Git repository, did we?
No. I will post a link to the notebook.
Okay, so I want to pause for a second and ask people that were trying to get on SciServe and we're trying to follow that part. If anybody has troubles, can you post that you have troubles on the chat so we can provide you with either personalized help or just go back?
Yeah, sure. I post the notebook on Slack chat.
I will put it on this Slack as well. Actually, you perhaps can you show a wget command from the terminal to pull that directly without
Yeah.
clicking? It would require you to go. Oh, you can do it from notebook. That's right. So watch out, that won't work because it's, oh, yes, that will work. So I want to point out that there is a raw word inside of this link. Can you show people how they would do that? They'll get that link with the raw from the GitHub repository.
Yeah, I also post the wget command link. So just run this in terminal or in Drupal notebook, and you should get the notebook in current folder.
That's right. Note that you have to get the raw link. So can you show the GitHub link and how you get the raw link from the GitHub link?
And for the raw link, you go to the download and copy the link address.
Thank you.
Yeah. So the spatial selection, I will quick demo how to select part of the sky. Use the HuPy. The HuPy provides some query functions to query pixels inside the polygon and the disk. We can define other functions to query other regions like galactic plane. So first you will need to update your HuPy. Use this command because the default version missed some features. We import some function. So before I start, I prepare a pandas data frame to store the coordinates between all systems, so I don't have to convert every time. The field data frame have pixel ID and array right declaration in galactic coordinate and also a star density map. So the HuPy HuPix map is just a one-dimensional area. So it's split the sky into 12 basic pixels, and inside each pixels is then subdivided, and the total number of pixels, it depends on how many cells are inside by the inside and these parameters. So here I use the inside equals to 2 very low resolution version to visualize the 12 basic pixels. HuPy provides some projections to visualize the more wide and mnemonic, Cartesian, and also graphic and azimuth, so equidistant views. Next, I will use.
Is that CSV file available for people to download? Like, can they git pull it like they git pull the notebook? Or wget it? The CSV
wget will get this notebook, and
right.
no.
But is the CSV file in the same repository so they can find the link to it? Is it uploaded on the repository?
No, not the CSV file. No, the CSV file is not uploaded. The CSV file just run these several cells.
Oh, I understand.
Run this part. Run this prepare field.csv, and it will create a field data-free CSV file. So this is quick. It takes several seconds to prepare fields. And next, I use a higher resolution to select pixels. I use 6 inside equals to 64.
How does that compare to the resolution of a single LSSD Rubin image? What is the closest hill peak size to an Rubin?
Yeah, so the resolution is equals to the total area divided by the total number of pixels. For this can be get from pixel by pixel to what that function. I'm sorry, to the resolution, yeah. 64. This give us the.
That's in radians.
Radius, yeah. In radius.
Okay.
You can say degrees equals true on that call and it'll make it readable.
No.
Yeah, maybe degrees with an S.
Plural.
Or that.
Degree.
Sorry, I didn't mean to ask a trick question, but I think it was important for me to understand how that resolution was compared.
I think it's about a half degree.
Oh, there you go.
1 degree.
There. Degree.
Also, there is a question on the chat. It looks like peaks to array deck was not defined when Franz tried to run the cells. Can you show where you get that imported?
Which array?
Peaks to array and deck, which is a function that you use to cell.
Building the fields. The fields.
There at the end of the notebook, there are some utility functions.
Okay, run the last.
So you need to run the last thing before you run everything from the start.
Yes.
Yeah,
so run the last cell first.
Last first. Yeah. Some coordinate conversion functions. Yeah. So the HillPy provide function to query a polygon. Like we can first define the vertices of the polygon and use this HillPy.query polygon to get the pixel IDs inside this polygon. Once we have the inside polygon, pixels inside the polygon, we can create a masked map by upy.ma masked area. The field value, the default field value is need to fill by upy.onSay. Fill this, and we use the move view to visualize. We got the polygon. And for the disk, the process is the same. We define the disk center and the radius, and use query disk to get the disk inside, pixels inside the disk. Yeah. And HuPy also provides a function to query strip.
Actually, can you show how you did the, so is this a different parameter to exclude this, sorry, to visualize everything but that area versus to visualize the area that you have chosen? So you're using is in for what is inside of the disk.
Yes, use the is in. This is the all pixel IDs, and this is the pixel inside the disk. So use the is in to create a to track which pixels is inside the disk. So yeah, query strip, the process is the same. Define two angles and use query strip theta1 and theta2. We got a strip area. We can also combine multiple shapes, like if we want to query a circle, we can define two disks and subtract the pixels from one disk to another. And we got use the setDiff, NumPy.setDiff to get pixels inside the range. Yeah.
Very good.
And the next thing I want to show is to select a galactic plane. This method is I copied the function from Will's notebook, and this function define the galactic plane by the bar size and the width. This function returns the galactic areas. Returns the boundary of this galactic plane, and we can track by the galactic coordinates which pixels is inside this plane, and select the galactic plane. Yeah. In the equatorial coordinates. For other if we want to select other irregular shapes, and HuPy doesn't provide these functions, but we can use some interactive tools. I will show you a tool which is written in JavaScript. So this is you can select the coordinate system and on side. In here, you can select any pixels you want. The pixel IDs will show below in this box, and once you finish your selection, and you just copy this pixel ID. In here, I select a pixel looks like LSST. This is the pixel ID for LSST, and I create a masked map. So run our map only on LSST region. So the last part, if we had the pixel IDs inside the region, how do we run our metrics? And there are multiple ways to do that. The first way is we can define a mask function inside our metric class to track if this field is inside our mask. Another way is to use the user point slicer, and we can convert the pixels to RA and DC and use the user point slicer to run our metrics only on this region. This way is faster than the previous one because it's only query pixels inside these regions. And so you can see the plot result and the histogram. In this test, I just calculate the mean of the column is AMS for each pixel. Yeah, so this looks like LSST. Yeah, so this is how.
There's a quick question on the chat, which is, I think, of interest to everybody. Wei Zhangyu asks, is the JavaScript code on GitHub?
Yes. It's included in the notebook. Where is
the JavaScript code, Xiaolong, the JavaScript code is bokeh, right?
The bokeh can also do this. I show here, this one is in D3 JavaScript.
Okay.
Yeah. The bokeh version is also included here inside the notebook.
So Wei Zhang, I will talk to you to see if you want to pull some of this into the repository that you and Gordon have so that it's available from the same place, or else if that's not the best option, we'll just provide links on Slack.
All right, yeah, sounds good.
Okay. Yeah, so I will stop here, and if anyone has some questions.
And Xiaolong is also serving as a mentor, you know, as long as he can stay awake. And so you can also find his contact on the mentors list. I think with that, thank you very much, Xiaolong. Also, there is a request to add some comments in the cells of code that describe what cells of code do. And I want to point out that Xiaolong gets the bad habit of not doing it entirely from me, so I'm entirely responsible for that. Yes, we should add some comments. You should add some comments to this notebook that that correspond to what you said in the video. But thank you very much. And I think with this we can. I think maybe we can just move on to your tribe. Good, I see you all again. Unless there are any questions.
I have one question, Fed. People are most productive if they get a break at some point in the morning. So how are we going to organize that?
Yes, so
I say morning, whatever time zone that is for you.
Right. I think originally we had thought that the breakouts would self-manage that. But perhaps this is a good time definitely for a 10 minutes break. I intend to go and make myself an espresso, which I have a very fancy machine, so it takes about 10 minutes. So I will be on your tribe in 10 minutes. Maybe we can convene and expect that everybody will be on break for the next 10 minutes. And then after that, breaks are self-managed by the different breakout rooms.
Very good. And we reconvene in a plenary session to summarize the content of the breakout at the end, or what?
So we had, I think the last version of the schedule doesn't have that because we figured that we wanted to let people sort of self-pace the work once they get into the breakout rooms. So we would just jump into breakout rooms and we'll write a report, which we'll share with all the participants about what we hear from each breakout room. Also, same report that will be presented on Wednesday, where I hope to see all the participants at the opt-in session of the PCW. Okay? I will see you in a bit.